All right, here we are. So as I had mentioned, we're going to have our first presentations today. We have 5 teams lined up: Codent, HZWZ, Programmers for Fun, the Compiler Whispers, and WSRY. Okay, so which team would like to go first? Just speak up. Okay.
I think we're gonna go first.
It's just a second. I have my speaker down really low. Yes, who is that again?
HTWZ.
Okay. If you want to go first, then I will allow you to share the screen, and I'm going to turn on the survey. So just a second here. Let me allow you to multiple participants. Okay, so you can share your screen, and now I'm going to go into Canvas and turn on the survey. Okay, hang on, let me find it. It's gonna be under quizzes. Whoops, just a second. I'm turning on the All right, can everybody see the survey? Okay, now the surveys each has a 20-minute limit, so be sure to fill it out either during the presentation or right after, okay? Okay, so take it away. You have about 15 minutes.
Okay.
Okay, Professor, can you hear me?
I can hear you and I can see your screen.
Okay, thank you. Okay, so hi, good afternoon, everyone. I'm Hong Kai. We are group HCWZ, and today we will be present our final compile project. And there are my partners.
Hi, I'm Rui Hua Kai.
I am Chen Hanbian.
My name is Chen Kai Yang.
Okay, good. Okay, so let's start. So for our compile project, we come up with a source language called Elong. It stands for English programming language because when people are reading our language, we want to make them feel like they are reading English articles. So we use lots of English words as our operators. That's why we call it Elong. Okay, so for Elong, we have 2 basic data type, which is simple type and array type. Besides, we have all the mathematics operations. All of our mathematic operations are by abbreviation. For example, we are using GT, stand for the great len, ST stand for small len, and GE for great equal, and NE for like no equal. So the only control statement we have now is if and else statement. Currently, we have 2 loop statements, which is loop until and loop to, which are some like interesting statements. And our language is supported calling procedures with calls and returns. The way we call procedures in the main program is using call a name of procedures and then passing the parameters. And my partner will explain them in detail. So there are some advantages of our Elong language. So the first, the code is kind of easy to read and understand. We have lots of pseudo code. It allows the programmer to focus on the main logic without being distracted by programming language syntax. By the way, like I talked before, we are using the abbreviation for all the mathematics operations, which means we will have like less symbol, and so it won't be too confused. Moreover, our code is very similar to other popular programming language. So we believe that our code will be friendly for learning. Now I'll pass to Rui Hua.
Okay. Now I'm going to talk about some interesting statement in our programming language. The first interesting statement is pretty simple and easy one. It's our assign statement. So in our language, our assign statement is unlike the most programming language. Usually, in most programming language, the variable will be on the left hand side of a assign statement. But in our language, we put it on the right hand side to fit into the assign something to something sentences. So next. So when you look at the actual sentences, you can see that every sentence is very easy to understand and read. You can just simply read assign 10 to I. It's very easy to understand, and you can see this is how the parse tree is being generated in the grammar code, and also when we are doing the math operation, we will do assign x at A to I. This is our assign statement, which is a pretty simple and interesting statement that we have. And then next, the other interesting statement that we have is loop 2 statement. So the loop 2 statement is different from the usual loop statement. Usually, the programmer will have to create their own variable in order to be the condition for the loop to continue. So in our loop 2 statement, the programmer will just simply specify how many times they want this loop to loop. So you will see that loop 2, and then in the bracket, usually where people put expression, we use a integer constant here. So you will just put, like, if you only want to loop for 1 time, you just put 1, and loop for 5 times, you just put 5. It's pretty straightforward, and then we execute as the time how many times you specified. Next page. Here you can see the some sample code of this statement. So you can see that loop to 5, and then it will execute whatever below. Compared to the other statement like while, you have to create your own variable. Sometimes when you are running a large program, it will be hard to keep on track of all the variable that you are using. But this one, you don't that doesn't require you to create your own variable. You can use it very easily. And also, unlike the for statement, sometimes people get confused about how many times their loop is looping, because sometimes when you do like I equal to 0 and then I less than 5, you loop for 5 times. But if it's do I less equal to 5, you loop for 6 times. It's very confusing. So in here, you just simply need to write 5, and you will loop for 5 times. So you can, it's more straightforward, like what we want for our language, simple and straightforward. Next. And another interesting statement that we have is a together statement. So this statement allows us to combine two arrays together. This is very convenient for many applications, since usually programmer will have to write 2 to 3 loops in order to implement a function like this. Writing this will much simplify the programming process. And go to next. You can see some simple parse tree of these functions. In here, we are combining 2 string array. Hello, this is HCWG, and combined with a test program. So supposedly after we run this, we will generate a hello, this is HCWG test program. So these are some interesting statements that we have for our programming language. Now I'm going to pass to my teammate to talk about our languages sample program.
Can you see my screen? So right now we have 2 sample programs for testing our language. The first one is for testing the if statement, and the second one is for testing the loop statement. We're also going to test assignment statements, print statements, and return calls in both test programs. So here's our first sample program, which is mainly for testing the if-else statement. Let me show you the parse tree. As you can see here, in the parse tree, we have 2 parts under the program. First one will be the declarations, and the second one will be the main block. And the statement list will be between the start and the finish. So under the declaration part, we will define our function like routine and statements under it. In this example, we have a procedure head with the void hello and the print line statement. Under the main block, we will have a variable declaration statement and a variable identifier list and a type identifier, which will be the variable types. Now we can declare these variables under both routine parts and also the main parts because we use the variable declaration as a statement. For our if and else statement, it also have a true and a false statement like other popular programming language. Once the expression is true, it will go to the true statement, otherwise false statement. And here's our second sample program, which is called test loop. It will loop the statement list until the expression becomes false. I will show you the part tree for this program. So here's the part tree for this program. And also we test the next loop in this program. You can see there's two loop statements here. Yeah, two loop statements here. So that's basically our sample programs. We're also making a more complex program for testing all the statements we have, like together statement and the loop two statement, what I just mentioned before. My partner, Cheng Kai Yang, will introduce the Jasmine object code next.
You only have about 2 minutes left.
So for the Jasmine code, the first Jasmine template is to loop. It's our loop two statement. The left side is our source code, and the right side is Jasmine template. The idea for creating this loop two statement is to give a straightforward way to loop how many times our programmers want by directly assign the integer number when calling this statement. And to realize our loop two statement in compiler for Jasmine code, first we declare a variable to record the number of times programmers want to loop at the beginning of statement, and it will decrement. The variable will be decrement at every loop finish until it becomes 0, and the loop will stop. And for the second template we are giving is a if statement. For now, it's like mostly all the other coding languages. So it's not very special to talk about. It's the same logic to like C++ or Pascal. And here you can see the Jasmine code template. And I'm finished.
That's all for our presentation. Thank you.
Thank you.
Okay, and any questions? This is a very good presentation. Okay. I might want to point out that the idea of an English-like programming language is not new. You may want to look up the language COBOL, C-O-B-O-L. And this is a language that was developed in the early 1960s. And the claim was that you write your programs in a very English-like statements. And you can take a look at it and see what you think. If yours is better, or if the people 50 years ago or 60 years ago had a better idea. Okay, so that's COBOL, stands for Common Business Oriented Language. Okay, COBOL. Okay. All right, and any other comments or questions? Okay, I will be very anxious to see you compile these programs and actually run them. It looks like you have the start of a very interesting language. Okay. All right. Anybody from the audience? Okay. Now be sure to fill out the survey. Okay. You have another 5 minutes to fill out the survey. Okay. All right. I think Codent wants to go next. Codent, you're up. Let me turn on your survey. Okay. Hang on just a second. Yeah, go ahead and start. Yeah.
Is the survey on the canvas?
Okay. Yes, Canvas has the survey for HZWZ. Look under quizzes.
Okay.
And I'm turning on the Codent survey. Okay.
Okay.
All right, Codent, you're up.
Sure. So are you ready, guys?
Yep.
Cool.
Yes.
All right, go ahead and share your screen.
I'm sharing. Can you see my screen?
Yeah. Yes, I can.
Okay, let's get started. So this is group Codent. This is our compiler project presentation. Our teammates are Zhongling Ye, Zhao Qinli, Sanjay Kwok, and Thomas Logan.
Hello. So our compiler was written in C++, and the target language that we created was called X. And this is an example of one of the files with .x. And it's, as you can see, based off of C. Next slide. So this is our data type and type checking. So variable locals and type, we're creating a slot to store information regarding the type, and an entry, we're creating memory to store everything that's inside the variable. And right below that with modifier, you can see that with any of our types, you can make it into an array. And once it goes through its second pass, calls its identifier and creates either int, float, char, boolean, etc. And then towards the bottom right of the screen is an example of our type checking. Next slide. So these are all our arithmetic operators. We have relational, addition, and multiply operators, and these are all pretty basic. And then on the next image right here, it's showing that you can have incrementing and decrementing behind the variable and also before the variable. Next slide. So this is our precedence with expressions. So basically we're creating the parse tree for the expression right here, which is a combination of factors and terms. And the terms are related to all our additional operators, and the factors are multiplication operators. And then the expression is made out of a combination of simple expressions. Next slide.
For assignment statement, it assigns left-hand side and right-hand side, or variable increment or decrement variable. For left-hand side, it can be variable or variable declaration. For right-hand side, it goes to expression statement. Next. For conditional control statement, we have switch, if else, and conditional operator. For switch statement, it's expected switch token, then parentheses, expression statement, and curly brackets, and switch case list. For switch case list has case branch, 0 or more, and default branch that can be multiple statement. For case branch, first case token and number colon and scope statement. For default branch, default token, colon, and scope. For if else statement, it's expected if token and parentheses and scope. Optionally, it has else if and else. For conditional operator, it goes to simple expression. Optionally, it has real operator and simple expression, or expression, question mark, expression, colon, and expression statement. Basically, they are similar as C or C++ language. Next. Looping control statement, we have for, while, and do while. They are also similar as C or C++ language. First, for statement, it's expected for token and parenthesis statement that can be multiple statement, and then semicolon, conditional expression, semicolon, and statement. It can be also multiple statement and goes to scope. For while statement, first while token and parenthesis, expression and scope. For the while statement, it's expect the token and then scope, while token and expression statement. Next.
We have a called scope like in feature in the C++. It is the content in the curly braces. So when you have a scope, it will push a new symbol tab, and you can declare variables that have the same name outside that scope. So you see in this picture, it's declare an int I and assign the outside I to this variable. And the variable will not affect each other. And also this exists in like the for loop if statements, these also have scope concept. And especially for the for loop, the initialization is also in the scope it has. And next slide. So our function is our function definition and declaration can be separated. When you want to call a function, you need to declare it first, or you need to define it first, or you have a declaration and definition after the place you call that function. And we have a return statement. You can return anywhere in the function, and it will check the return type with the expression you return. And if it's different, it will cast the expression to the type, to the return type. And even if you don't write return statement, it will return default with a 0. So this is the same as C++. Okay, next slide. You can pass different type arguments to the function, and then it will cast the argument to the parameter type. So all our parameters are passed by method because for some reason Java can't. I would say it's hard to do the pass by reference. Next. So our basic error recovery is pretty straightforward. When there's an error, it will set the type to the default type, so it will not affect the later grammar to get the type, and it will stop the function right after the flag is exists.
Okay, so since you guys got you have the explanation of the compiler, let me give you guys a brief demo of our compiler. So can you see my screen? See another screen?
Yes.
Okay, thank you. So this is 2 test cases that we prepared for testing this compiler. The first test case I'm going to talk about is the ALU.x. Basically, is acting as an arithmetic logic unit that allowed user to choose corresponding arithmetic or logic operations in the input, and also input 2 operands for calculation, and for the function will return a result for the representative operations. So the first thing I want to talk about is the lookup, is the switch operation, or the yeah. So once I run this, it will generate the Jasmine assembly code on the right side of the screen. Okay, let's go over that first. So for the switch statement, we use this lookup switch instruction that basically will combine the input. Will link the input the input mode integer with the corresponding label Let's say if the input is 0, if the case 0, that mean the case branch is 0. The loop, the label 005 will be called, then do the operation of arithmetic shift right. When the input is 2, when I load 2, which is I load 2 is when you load the mode, and then when the input is 2, it will go to the label of 007 and do the return and do the logic shift right operation. Okay, so we have both arithmetic and logic shift right in our ALU function that I will be demo later. Second thing is the function definition that I think one of our teammate has mentioned before in the PPT, that our compiler take the function definition after the allow function definition after the main function, but we do need to predefine it at the top of the file. Also, the global variable is allowed it, just like C languages. And let me run this. And for example, if I want to do a modulo, which basically tell you what's the remainder of 2 operands is, I'll type 4 and I do 19, 2. So you can see that the modulo is actually 1. Okay, the 19 divided by 2, the remainder is 1. Okay. So you can see that we also support that. Because we have casted our variable type when we do type checking. So we also support a mix of float variable and integer variable calculation. And that is usually that wasn't supported before. So we did some work and make that available for calculation. So we can do a float combined with integer. For here, you can see example of post-increment calculation and pre-increment calculation. That post-increment will basically first assign the value of C to D, and then increase C, while the pre-increment will first increment C and then assign the value and print out the value. So as you can see here, right, like the 3 outputs. So let me show you guys about the shift calculations that we did. Okay. So if I choose shift and I do 0, which is arithmetic shift right, and I type -5, and this will definitely -4. Let me do. This will definitely give me -2 because arithmetic shift right basically is divided by 2. However, if I do logic shift right, it will definitely give me a huge number, because since logic shift right will replace all the most significant bit with 1 if the operand is negative. Try this, -4, 1. As you can see, this is basically the limit of an integer value. So this is huge. Okay, I suppose these are 1, 1, 1, 1, 1, 1, 1, and the value that we actually getting, and 0, 1, 0, because the actual value is -2. The shift results. Okay, so let's go to the next test cases, which is the search.x. So the search.x basically do mention our array availability, that we can create our array and modify its content, and using a do while loop, and using a do while loop, and for the user to search whether an input value is matching any of the array element. So first, the function will ask the user to input the first, second, third, and fourth number of the array that you want to put, and then you can input another value to search to find whether the number is matching. Okay, run that. So there's one interesting feature in our compiler that I want to mention is the conditional operation, which is, you can see the question mark right here. It basically acts as a if-else statement, but it's much more convenient to use. basically what it says is it's testing whether the I is equal to 1, because I want to print out. So if you look at my output here, I wanted my program to say, oh, the 0th number I will be 1, and the first, so st, now it comes the first number I want it to be 2, the second number will be 3, the third number will be 4, and the fourth number. So these outputs are changing because I'm using this conditional operation that that is basically a if-else statement that keep branching to other label. In the Jasmine assembly code, you can see that there are actually 22 branches. There are 24 labels for the branching, and this keep testing whether the operand I, the variable I, is equal to the test value constant of 1, 2, 3, and if that is true, then it will go LDC, which is load content, to the current output, and use that and use the use that and invoke virtual to print out the corresponding LDC value. So let me input my last value, which I'll say 4, I'll say 5. And if I do, so now it's asking for me to enter a search number. That if I do 3, it'll tell me that the index is 2, which is matching what I was input. Okay, I think this is end of our demo. And thank you very much.
Wow, very impressive that you actually have working code already.
Yeah.
So one quick question is, how did you implement the nested scopes? Say if you have a variable I declared in a nested scope.
Yeah, let me share my screen.
In the semantic checking, it will push a new symbol table that inherits the slot number.
Okay, so that means a function can have multiple symbol tables depending on how you nest the scopes.
Yeah.
Okay, very good. Any other questions from the audience? Okay. All right. Well, thank you very much. Very well done. Okay. I think Compiler Whispers wanted to go next.
Thank you.
Okay. So take it away. Oh, let me be sure to do the survey for Coden. Let me turn on Compiler Whispers survey. All right. So Compiler Whispers, take it away. All right, I see your screen.
All right, hello everybody. We're Compiler Whispers. My name's Angelo.
My name's Ant. Yeah.
Excuse me, I'm Sabrina. Sorry,
Yeah,
I had trouble.
All right, my name's Ant.
All right, and so the language we use is, the source language we use is C++ and Pascal. The declaration and decision structures are like C++, and the program begins and ends like Pascal. And so the inspiration for this language is the common phrases and words used in like a cartoon show. And so we wanted it to be a fun project. So like, we're all really excited to do this. And I think another inspiration is like, we get to be really creative in the kind of statements we can replace with. And so drum roll for the language, which is inspired by SpongeBob. So the next slide will also be showing a sample program.
So this is the first sample program. So we're trying to testing the do while loop. So the program name called Bikini Bottoms, I kept it. And we're trying to make the I is equal to 5. And we used value already give me for the do statement. Also, we use order of to print out the I. Also, for the while statement, we use the formally, and the end is for the goodbye friends.
Just in case it's got the reference. Oh, I don't think the sound is showing.
All right, so the next one is the pass tree for the sample program.
All right, so this is the sample program we have. At first glance, yeah, it's incomplete right now. Something we need to fix with our grammar file, but we wanted to show it just to show the intention of what we're trying to do with the program. So we could just go through it. So On the left-hand side, we do have the assignment statement. Our variable I is being declared as 5. And so the do part of the do while isn't being picked up. And we do think it's because our grammar file, we're not allowed to redeclare a variable, or the ravioli gave me is being detected as an expression, then not a statement. But the while statement on the right-hand side is working. As you can see, we have the formioli, which is the while, and then an expression within the parentheses. And there we have I is less than or equal to 10. And Angelo will then show the next sample program.
So yeah, this sample program will just showcase a simple if statement. On the right side, you can see just pseudocode, and the code will determine whether you have enough money to buy a Krabby Patty at a fancy Krusty Krab, because a Krabby Patty is usually $1, but it's $25 here. And first of all, just want to note that we haven't implemented anything to take input from the user yet. So we'll just use this variable called $, to represent how much money we have. And so we make that equal to 10, and II captain is like our semicolon to end the statement. And for our if statement, we use F is for friends, because if sounds like F, and F is for friends. And you can play the clip. I don't think it'll show, because I don't think you shared the sound. And then after that, it'll do the print statement, which is order up. And it'll just say order up Krabby Patty, II captain. And if it's false, if you don't have enough money, then it'll go through the else statement, which is F is for fire. And then the print statement will say order up psych, because you're not going to get a Krabby Patty since you don't have enough money. And that'll be the end of this sample program. We're going to be showcasing our parse tree for this after that.
All right, so same thing, just the parse tree for the sample program. This one is actually more complete than the previous one, so we could just go through this as well. So yeah, program headers, bikini bottom, and then the compound statement is an eternity later and goodbye friend. And then on the left-hand side, we have the assignment statement, where we're declaring the variable $, as the integer 10. And then on the right-hand side, that's where the if statement is. And like Angelo said, the if statement that we're using, or that it's labeled as, is F is for friends. And then we have an expression there, and we're doing $, is greater than 25. So you have to have more than $25 to get a Krabby Patty. That's what we're trying to go for. So if that's true, then it goes to the right statement, which is simple order up Krabby Patty, which is our string. But in this case, since we did declare $, as 10, it's going to go to the false statement. And for the else, we have F is for fire. And then same kind of concept here. We have a right statement that has order up, and then the string constant is psych, because we can't get a Krabby Patty. So Sabrina will talk more about the grammar.
All right, just to like side note here, sorry if there's like noises in the background. My neighbors are doing construction right now. So I think we're all like really excited to do this, especially me. I grew up on SpongeBob, and my cousins watch it every single day. So I'm kind of like a SpongeBob encyclopedia here. So here we have Krabby Patty for factor. Everything else it's pretty consistent with the professor's grammar file. And then here for not, it's Doodlebob, because it's the opposite of SpongeBob. And then T-bun and B-bun are top bun and bottom bun. And those are like the parentheses that are surrounding expression. And then variables the same, numbers the same. Thanks. Bubble Buddy and SpongeBob is integer and real. And then Plankton is a character because he's small. And Squidward is a string because strings are boring. And then here, I think we were all excited for this one, because the if statements, the decision structures, and the while loops are like the funniest ones. So F is for friends is the if statement, which is inspired by the F is for friends song. And then F is for fire is Plankton's version of it. And then true statement, false statement, those are the same. And then do while, unfortunately, this one doesn't work, but this is the funniest one. So we're gonna work really hard to get this done and have it working. So ravioli, ravioli, give me the formioli. It's a really great episode. And then right statement, it's order up. And then our semicolon is I captain. And then right line statement is you forgot the pickles for bubble bass, SpongeBob's arch nemesis. And then magic conch is the new line. And then relational operations, those are the same. We didn't really know what to write for those, but we might end up changing them just to be on theme. And then add operation is money, and me money for Krabby Patties, Mr. Krabs, because Mr. Krabs likes getting money, but he hates losing it. And then the mult operation, it's I went to college for multiplication, and I will destroy you all for divide, because Plankton doesn't like getting divided into. And then or and are the same.
All right, so these are just the syntax diagrams. We just wanted to show the ones that we were testing in the sample programs we showed. So just the if statement, right, and the do while. So Sabrina kind of already touched on this, but the visual notation of if, as you can see, we just have F is for friends as the if statement, and then the parentheses, top bun, bottom bun, that's around the expression. And then starfish is our version of like brackets, but it's just the asterisk on the keyboard. And then within that, we have the true statement. And then the false statement is with F is for fire, which is the else. And then right statement, pretty self-explanatory. It's just the order up, which is like print, and then the argument within the parentheses. And then like Sabrina said, the do while is one of the things that we were excited about because of just the comedic part of it, but it's not working right now when we're running the sample program. But this is how the syntax looks currently. So yes, just ravioli, ravioli, give me, and then statement within the brackets, and then the while, and then the expression. And that's it. Or thank you.
So are there sample programs you've written?
I believe we showed it in the presentation. We have like sample programs, but
well, I mean, have you decided what code to generate for the sample programs? I mean,
not yet.
Not yet. Okay.
We were busy making the grammar file work because the do while statement doesn't work and a few other ones didn't work, but we got most of it to work except for that do while statement.
Okay. Well, it looks like your language is very similar to Pascal, other than the fact that you have much funnier reserved words. So you should be able to use a lot of the code generation for Pascal to make this work.
Yeah, we wanted to base it off of C++, but I think it'd probably be easier to do Pascal just because we're creating a completely like new language.
Yeah, you want to keep the number of variables or keep the number of options down so you don't overwhelm yourself for the next couple of weeks. Yeah. Okay. Any questions from anybody else? Okay. All right. Very good. Thank you. Be sure to fill out the survey. Okay. Now I think Programmers for Fun wanted to go next. So why don't we do Programmers for Fun? Okay. Thank you very much. compiler, is it compiler whispers or whisperers?
Whisper.
Compiler whispers.
Okay, because I got compiler whispers early on. All right. So programmers for fun, I'm turning on your survey. Okay, take it away.
Is everyone ready?
Yep.
All right. Hello, everyone. We are Programmers for Fun. My name is Jesse.
I'm Dion.
All right. So an overview on our source language. So the source language our group chose to work with is Golang, also known as Go. And it's a fairly new computer programming language that was developed by Google in 2007. And I think it was only released to the public in 2009. So the language was loosely based on the syntax of C and aimed to avoid many complicated features that other modern languages had, such as method and operator overloading, pointer arithmetic, and type inheritance. And one of the main reasons we chose Go as our source language is because it's a procedural language, and procedural languages are easier to work with compared to an object-oriented language. And since we don't have the normal time frame to fully develop a compiler, we thought it was easiest to choose a procedural language like Go. All right, so now I'll be presenting our parse tree. So we have a fairly simple program written in Go. It has two functions. One is a function called greeting, which will return our string, and our function main, which will be able to call the function greeting and also print out a for statement. So on our right, the syntax tree, we have, so first of all, we have to detect the package, right? Package clause, which is similar to looking for our program declaration header. And then we have the import declaration, which looks for import FMT, which is similar to looking for an includes library in C++. And on our top level declarations, we have our function declarations. Move over to the right a bit more. So we have two top level declarations that goes to two different function declarations. And one goes to the function greeting, the other goes to our function main. And on our left function declarations, we see that we are parsing to the greeting functions and looking at the parameters. So we have a name, which is a string type, which will return a result of string. And if you notice the block, so one of the most noticeable difference between the parse tree of our code versus Pascal's parse tree is that there's no compound statement in the tree to execute the program. Instead, we have to locate the main function in order to do so. So once we go through the block, right, we visit the stimulus, and then we see what we need to return, which is hello, and then our string variable name. Then if we move over to the right side a little bit more, same thing. We go through the block into the stimulus, and then we see that we're parsing our print line statement, which will call the greeting function, right, and print out what we've written. And then if you move over to the right a little bit more, we also have the statement, a statement going to the for statement, which looks for our variable for, right, recognizes a for loop, and then goes through our parameters such as I equals, or a short variable declaration, I equals 0, and then I is less than 5, and I plus plus. And finally, we see that we visit our print statement, which will print hello world. And now I'll hand off to Chris.
Hello. So to add on to his performance optimizations of Go, I think for the case of the grammar file, Go with Antler 4 achieves even higher optimization and flexibility. And as we all know, when fed Antler 4 grammar, the source language, it automatically generates a scanner and parser for that language. Because of this feature of Antler 4, we were looking for a language that would be optimization driven, like Antler 4 for its grammar. And Go became a perfect language for us because it was tackling some issues of C, but also wanted to be at the speed of C. It doesn't involve interpreters. It's a multi-threaded language. And the syntax declaration is kind of backwards and weird, but also at the same time, it's simple and easy to understand. So with the grammar file, can you zoom in a little bit? Sorry. We found that there was less implementation that we had to do. Especially because of its package calls and
we're losing your audio.
hello, can you hear me?
Okay, much better.
Okay. But yeah, especially in those railroad diagrams, we saw less looping of paths and a more straight, efficient routes in the execution of the function.
We've lost your audio again.
Hello?
Now you're back.
Sorry, it's on my phone. But yeah, Go's language proved to be faster to implement and was definitely faster as well. For the statement functions, such as the for loops or if loops, those railroad diagrams definitely became more compact and less nodes to go through. But yeah, that's the case of why we chose Go language and for the use of for the grammar. And next. Hello?
Hello. I guess we're going to the next one.
Hello. I have a couple of code templates to share. So on the left is, I wrote looping, but this is more for the for loop specifically. So there's some code for generating the variable assignments. And then there's a loop label at the top. And then you set up the test for the Boolean expression and you have code for evaluating it. And then If it is false, you jump to the end. And if it's not false, you continue. So you do an increment or a decrement on your variable. And then you have the body of the loop and you jump back up to here. And then the assignment statement template. And this one I know for a fact is implemented and we have the Jasmine code, set up to be emitted for this one. I don't know about for the for loop yet, but I know for the assignment we do. And that covers, there's a check for if the variable has any subscripts or fields like an array or anything. And then you evaluates the expression, and there's a block for checking if we need to convert integer to a float, if necessary, to store an integer number into a floating point variable. And then we emit the code to store that expression into the variable, and that handles if it's an array or a field element. And that is the templates that I have drawn up. Okay. I think next is Tian, right? Hello?
Yes, I will be
Okay.
next. Okay, as you can see, we generate some object code for Jasmine, and we just generate some fundamental codes of making use of the function calls and then returning them from the functions. As Natia has mentioned before, we were able to get the assignment statements to be working with it. And this is how we will declare the variables in Go, as you had to do a var and then the variable name, and then you'll do the data type is. So we have the integers for the data types for integers and strings. And you can see here, we're just printing them out, hello world and a var, and then we're trying to return a function call here, and then return a string from the RT function. And then we're just gonna call again without the returning of it. And as you can see in the Jasmine object code itself, how it works was that when we go down to look at it, right here, you can see this is the storing of the function call back into the variable slot, and then we could see it again here. We're just calling it, and this time we made it so that whenever a function call is made, if it's just a statement itself, we're just gonna pop the return value. If it had not been a if it's not an assignment statement, we're just gonna pop it, since all return value or functions either return something or it does not. And since it does return something, we have to be able to pop it off as the stack in order to keep the Jasmine code running. So I already did importing in, and so I'm going to show it running. So if we do Java main, you can see that it ran on what it did. See that it went to the add world. Since we're doing the add function here, it just did all that, and then we did hello world, and then it got the 5 and 10, and then we went to the return value here. It get the S was a string world, and then we printed it, and you got the string world here, and then we just did the to return for 10 a world, and we could see it here. But that was what we basically got as of now. We still need to implement the if statements, the for statement, and the other two kinds of assignment statements that Go offers were just a shorthand declaration where it would be like C++ with the auto, where we'll assign it based on on the left-hand expression, as you can see here. But that was pretty much our presentation, and thank you.
It's very impressive that you actually have code that you can assemble and run. So I think you're on a good path to having a working a Go compiler. Okay, and any questions from the audience? Yeah. Okay. Now is Go object-oriented language, and you only chose to do the procedural parts of it, or is it just basically a procedural language?
Go is mostly a procedural language from what we have read. There's no object-oriented programming in it.
Okay, okay, so it really is very much like the C language. Okay, very good. And any questions from anybody else? Okay. All right, then be sure to fill out the survey for Programmers for Fun. And the last project is WSRY. Okay, and I'm just turning on the survey. Okay, all right, WSRY, take it away.
Okay.
Okay, I can see your screen.
Hi, so this is our team compiler project on Ada programming language. We are group WSRY. Our team member is Yi Guan, Zuofan Zhang, Yiqian, and me, Jiaxi Lai. Next. So Ada is a structured, statically typed, imperative, and object-oriented high-level programming language. There's three reasons that we choose Ada. First is that Ada is used commercially in many fields, including avionic, shipboard system, nuclear reactor control, train and subway system, and communication. Second is that Ada is unique in having standard feature of interfacing with other language. This make it easier to develop multi-language system, and it also make it easier to port such system across different platform and compilers. The third one is that it's very easy to learn, including the experience from Ada educator over many years. He said that with a 5-day hand-on class, a programmer familiar with a language such as C can become proficient in Ada. Later we will show like why Ada is easy to learn.
Okay, for Ada's loop statement, instead of having 3 separate repeat, while, and for loop structure like Pascal, Ada has put them together in one general loop structure. As you can see from the syntax diagram, there are 3 possible scenarios, one with while statement, one with for statement, and one without any of them. For our while statement, it is similar to C++ and Pascal. It has an expression that controls the loop. And for our for statement, the condition is a variable in a certain range of the array, which we'll show examples on it later. Next slide. The third case is a loop without for or while. It operates similar to the repeat statement from Pascal, which is keep looping until it meets a condition specified in a access statement. The access statement is like the break statement from C++, which can be placed anywhere inside. Can you go back?
Exit, right?
No, back.
Oh, sorry.
Back. Yeah, here. Okay. The access statement is like a break statement from C++, which can be placed anywhere inside the loop, even it's in a while loop or a for loop. Next. And this is an example of our ADA source code for a for loop, for a while loop. The program first checks for the loop type. It searches for a reserved word like while or for. In this case, the loop is a while type, so it operates the while loop. And after it checks the condition, it enters the loop. As you can see, the source code is easy to read and understand. It appears to be very close to English languages, which makes this language easy to learn for beginners. And this is a sample for our for loop statement. The condition part for ADA for for loop is a variable in a certain range, which is known for a subrange type. It stores the value from the first constant all the way to the second. The reserved word reverse makes the process backwards. In this case, you can see from our path tree. It's the character for loop. And the subrange type is from letter A to letter M. And here we have a loop statement without any headers. It is similar to repeat because it keeps going until it meets the condition in the access statement. What makes it better than a repeat statement from Pascal is that the access statement can be used anywhere for many times inside a for loop, inside any loop. From this example, we put the access statement in the middle of the loop, but for Pascal, the until statement can only put at the bottom of the repeat statement. And you can see the access statement is very understandable. You can literally read it out. It says except when I greater than 5, which means that the loop will exit when I is greater than 5. Okay, next.
Okay, here's our if statement. It's very similar to Pascal. However, it can handle more than one else if statement. As you can see, we separate the expression and statement with different names to differ the conditions, so it is more readable and manageable. Here's our sample of ADA source language for if statement and parse tree. In here, we can see that we have multiple else statements, and the exit statement will end when it sees the end if. For ADA procedures, it is similar to other language. The only difference is the way that it treats the parameters. There are 3 kinds of parameters: in parameters, out parameters, and in and out parameters. The in parameters are the parameters that are not allowed to change. In other words, these parameters are passed by values. The out parameters are designed to be modified and it does not have to be initialized. They are similar to pass by reference. The in and out parameters are designed to handle both cases. This is the grammar for the procedure. And here's our parse tree and sample program. We use in and out parameters here for integer A and B, which means that A and B can both be used for the values and can be reassigned. Next, I will show you the Jasmine code that our compiler generates. Here is the test while. It checks if I is less or equal to 5, and if it meets the condition in the while expression, it continues the loop, else it would go to the exit label and terminates the loop. For the looping, for the for loop statement, it will check for the word reverse if the word reserve is present. If it's not present, the program assigns the first constants from the sub-range type to the loop variable, and then loads the second constant to the stack and compares if the variable is greater than the second constants. And it does vice versa for statement in reverse. For the regular loop, for every statement in the looping statement, we will check if there's an exit statement. If there exists an exit statement, we load the expression into the stack for the condition. If the condition of the exit is met, it would go to the exit label. For the if statement, since it's not a looping statement, whenever it meets the condition, it will branch to the corresponding statement label. If none of the statements are met, it executes to the else statement and goes to the exit label. And next, I'll demo our code. I'll first run the test loop. And this is our source program for test loop. So it would simply loop until it meets the condition in the exit statement. So this is test while. And here's a sample program. So it would print hello world and the count. Test 4. For our test 4, we have I starting from 1 till 5 and print I. And then for J, it's reverse. So it would take the second constant, which is 5, and then goes down to 1 and print J. And then we also test for characters. So we know that characters works too. And this is our test if. So in here, we only have one else if statement. And for the second if, we have multiple else if. So we know that our if statement works when there's multiple else if statement. And this will conclude our presentations.
That's very impressive. One of the first programming languages I taught at Santa Clara University was Ada, and this was a long time ago. And Ada is used a lot by the military, the Department of Defense, make that a standard language. And when I was working at Lawrence Livermore, I found that there was an entire floor of programmers writing in Ada. So it's a language that's used a lot. And as you can see, it's based very much on Pascal. The uses colon equals for assignment, and the declarations are very similar to the way you declare things in Pascal, with the variable name colon and then the type. So yeah, Ada is a language that's being used a lot, especially if you're writing programs for the US military. I'm very impressed that you have working code, that you're already generating code and the code can actually run. So you're very far along in getting a working compiler. I'm sure your friend who's the Ada programmer is going to be very impressed when you show him what you can do. Okay. And any other questions or comments? Okay. All right. Well, I am very pleased to see what you have, because I expected that because this is the first set of presentations that you would not yet have working Jasmine code, and yet several projects already generating Jasmine code that can be assembled and actually run. So I'm very impressed by that. All right, any other questions about any of these projects? Okay, be sure you're filling out the surveys. Okay, And then when we come back on Tuesday, let's see, Tuesday, we will have 4 projects: Devs United, JTTJ, Team 300, and To the Moon. Okay. All right, thank you very much. Okay. I have been recording this meeting, so when I post the recording, then of course you can watch it all again. Okay. All right, thank you, and I'm going to end the meeting. I will have my office hour at 4:30, and yes, indeed, earlier today, this morning, I did post more internships opening up at NASA Ames. So if you're really interested in working for NASA, take a look at my NASA webpage. Okay. All right, thank you. I'm ending the meeting.